This is Mr. V. Welcome to this video series on linear programming. This video will be about graphing linear inequalities. So, a linear inequality is any equation like y equals mx plus c, but instead of the equals sign, we're going to have one of the inequalities. For example, this could be the less than symbol, the greater than symbol, the less than or equal to symbol, or it could be the greater than or equal to symbol. Which would mean, for example, with the greater than symbol, that y is greater than the linear equation. So here we have a linear equation. We've got y is greater than 3x minus 2, and we've got four different versions of this equation, with each of the four different inequality signs that we've got. So I'm going to show you how to graph all four of these. Now, to begin with, we are going to have to graph the line. So I'm going to choose to use the table method to graph the equation y, and I'll put an equal sign, but that could be any of the signs. Y equals 3x minus 2. So I'm going to choose some x values. I might make those -2, -1, 0, 1, and 2. And I'm going to calculate the y value corresponding to that x value. So when x is -2, y is going to be 3 times -2, which is -6, minus 2, which is -8. When x is -1, we'll have y equals 3 times -1, which is -3, minus 2, which is -5. When x is 0, y is going to be 3 times 0, which is 0, minus 2, which is -2. When x is 1, 3 times 1 is 3, minus 2 is 1. And when x is 2, 3 times 2 is 6, minus 2 is 4. So there's my table of values. And I will start with this one, which is y is greater than 3x minus 2. And I'm going to start by plotting the 5 points that we've got, just like usual. So when x is -2, y is -8, dot. When x is -1, y is -5. X is 0, y is -2. X is 1, y is 1. And x is 2, y is 4. Now y is greater than 3x minus 2 means that y always has to be bigger than this. So y can't equal it. It can't be less than that. It has to be greater than. Now the way I represent this with my line is that I'm going to use a dashed line to represent that y can't be any value in the line. So let's have a look here. Y has to be greater than this. So y could be over here. Y could be over here. Y could be over here. It can't be here, because that's not greater than the line, it's less than the line. And it can't be over here right on the line, because our equation says that y has to be bigger than it, so it has to be above it. So y could be any of the values in this region of the graph, this part of the graph. Let's try that with y is less than 3x. So again, it's the same values from the table. So plot those: -2, -8, -1, -5, 0, -2, 1, 1, 2, 4. Grab my ruler, and again this will be a dashed line because y can't equal this line. It has to be less than that line. That means y could be here, it could be here, it could be here. It can't be over here. It could be any value in this region below the line, so underneath the line. Now when we've got a greater than or equals, or a less than or equal sign, we've got the same deal. So y could be any value in this region, plus it could be anywhere on that line. The way we represent that is by using a solid line as well as the shaded area. So in this case, I'm just going to put my two dots in, and I'm going to connect these with a solid line. So this one, y is greater than the function, has a dashed line. This one, y is greater than or equal to, has a solid line. And we're going to shade that area that is greater than the equation. Same deal with y is less than or equal to 3x minus 2. Solid line. But as we know, it has to be the area underneath the function. So I'm going to shade the area below the function. So there we are. That is how you can graph any of the linear inequalities using the methods we've discussed before.